right, you're live.
All right. Hey, so here we are for session 5, I believe. And so first question is, any questions from last time? Somebody, Colleen, did I?
Yeah, I'm going to email you my questions.
Okay, great. Email me the questions.
Yeah.
I didn't fully figure out partly because I don't see your annotations on Google Documents.
Right.
So it's no good. All right. So today we're actually going to get into programming finally. However, I realized. I'd like to say I realized on the way over, but I realized on Thursday that there's one tiny detail in language which is so cool and very useful, and I in fact use without thinking about in this, so I'm going to teach it to you, which is multiple assignment. Now, multiple assignment solves this big problem you have in almost every computer programming language. Supposing I have two variables like I is 23, j is minus 9, let's say. Supposing I want to swap these two variables. Well, the trouble is, if I just say I equals j, right? Now I've lost that value 23. It's gone, right? So I have to, in most languages, you have to introduce what you call an intermediate variable. You say temporary equals I equals j equals t and p. And now you can see I and j are minus 9 and 23. No troubles. Okay, so there we go. But that's kind of annoying, and plus you find you're all the time doing things where you want to rearrange variables, or more interesting, you often want to return multiple values from a function. Hey, how are you?
Sorry.
You missed almost nothing.
Okay, good.
So I'm just going on about why the next part's going to be so great. In the classic computer salesman, it's going to be so great. Basically, the only in classic languages, the way to interchange two variables is with an intermediate variable. But there's a much better way to do it in Python. So here we have I and j. Oops, is I and j. Oh, I screwed up. Oh, I and I. Well, there we go. Voila. So if I want to interchange these, I can do this marvelous little trick, which is called multiple assignment, where I say I comma j is equal to j comma I. And now if I do I and j, you can see they switch places. Now, this is, you're like, okay, well, that's a pretty clever trick, but that's, you don't want to add language elements just make one tiny thing easier. But this turns out to be really, really handy when you're getting results back from functions. If you want to return multiple values back from a function, in other programming languages, you have to create a variable to store those and then pull values out. It's very messy, and here I can just say something, like if I say x equals 12 and a, then if I say a comma b is equal to x, it unpacks those values so that the first value, with my stick, I'm going to have to use my hand here, this is very primitive. So the first value 12 gets assigned into b, a, and the second value a gets assigned into b. This turns out to be totally handy. You use this all the time, and once you get used to this, you find that lots of your code magically vanishes as the results of one function can go right into another function. The classic way you use this is with dictionaries. For example, let's create a dictionary that looks like my classic one.
I'm sorry, could you just unpack what you were doing again before? I'm just a little lost.
No troubles. Okay, so which line here?
I'm starting at x equals 12.
Okay, so this is a tuple with two elements.
Right.
So what I've done here is this x gets unpacked into these two variables a and b on the left side. So that 12 goes into the first box, that a goes into the second box.
Okay, got it.
And you can actually do levels of unpacking and this sort of thing. You can actually have like lists inside lists to unpack to. You don't have to unpack just tuples. You can unpack lists. You can unpack iterators. You can unpack anything that looks like a list. And again, I don't expect you to necessarily remember what I just said, except for the fact that it all works as you expected. Classic Python thing. I didn't even realize you could unpack anything other than a tuple until I was looking at my code. I'm like, oh, I guess that's a list. Oh, I guess this works. So it's really nice when you look at this stuff and later say, oh, that's right, I didn't know that worked, but I guess it's all working. So the classic way you use this is with dictionaries. You use this all the time, but here's a very nice way to do it. You say, there's a thing called items in a dictionary, right? And you can see that this is a list of, this takes this dictionary and changes it into a list of key value. So a list of tuples, each tuple has a key and a value. So what you often say is you say something for key, comma, value in dict.items, print percent s, comma, percent s, percent key value. You didn't miss much. Slant dogs on you. And that's not going to work. I got distracted.
Yeah.
Key value. There we go. What did I do wrong? Oh. Okay, there we go. How embarrassing. I feel particularly bad because there's a video on. Voila. So you can see that, so you can see, well, you can see what happens here. Let me explain what's happening here. So this items is, as I said, a list of tuples containing key value. And then this for statement here. So this d.iteritems is that list. That tuple, each of these tuples is passed into key and value, so they're unpacked immediately. So the first time that this goes through, you can see we get this first dictionary item, which is 2 and 2. It's unpacked into key and value, and you print out. And then the second time through, we get this second tuple with the key and the value. It's unpacked into key and value, and prints that value there. I noticed some furrowed brows. So basically, what's a better way? Well, here, I bet you look puzzled.
Yeah, I kind of don't really understand the like the percent.
Oh, don't worry about too much about that. We can just set.
Formatting.
That's a formatting thing. That's, remember, string formatting. We have 2 forms of formatting. So basically, is this value is put in there in the string. This value is put in there.
Okay.
So the key in the first case is 2. It's put in that first percent. The value in the first case is 2, number 2. It's put in that slot there, and it's printed out. We do 2 of them.
And the S converts it to string.
So S converts it to string, exactly. The second one could have been a percent %d because that number happens to be a number. But as you know, percent %s just works for everything. Right. So that's multiple assignment, and I'm going to give, as usual, if you notice yet, is I go over the high-level thing, and then I give specific examples in the exercises. So you're going to get a bunch of exercises, which I haven't written yet on this part. Right, and I think that's all we need from language things. So now we're going to go to programming. You've been waiting your whole life for this one. And I'm actually going to do, I'm not doing it in PyCharm, because I am too slow and stupid on PyCharm, and I'm very fast in Emacs. I don't have to look at the keys. So, and again, as I should add is, I'm not requiring any editor. PyCharm is just convenient for me. I know you've had trouble with it, but you're already using an editor. You have your own editor. Darwin, I'm putting you here. He has an editor. He doesn't need the crappy PyCharm editor. Oh, it's pretty good actually, but any editor, you can use any editor you like for this. The only reason I recommend PyCharm is it's free and very Python-esque. Right. So I actually created a GitHub repository for this. Don't worry if you don't know what that is. I will give you instructions on how to download this and take a look at the code. So you don't have to write any of this because all of the code will be there. So the first thing I'm going to go through is what's called modules. Now, if you recall in our previous episode, we were able to import things like math. We did things where you said import math, and suddenly we have a huge number of math operations just sitting there writing your code for you. Well, that's all fine and dandy, but what if you want to create your own module yourself? That's something you want, oh, well, we're going to do it. You do. The reason is because once your code gets to be bigger than 1 page long, you're in a danger zone. It's very hard to read code that's too long. You find that bugs disproportionately occur. The further down you are in a big file, the more likely there are to be bugs. Your eye gets tired as you go down these things. You find it hard to navigate. These are very small pages. I'm not necessarily trying to fit these in, but when I get more than like 100 lines in a file, a little warning bell goes off. So, and one of the ways to divide things up is modules. So you find in practice you're doing this all the time in real world code. You cannot fit it into one file. So how do you make your own modules? Well, it turns out this is one of the really nice things in Python. Making modules is incredibly, incredibly simple. In fact, there is no way to write a program without making a module. And the reason is it's so incredibly simple. So let's take a look here. We have, let's start off with my simplest one. Is this my basic one here? No, sorry. Here's my module. Voila. So, let me just start with the top. Remember I taught you to squint sometimes, not to necessarily understand everything. Do you see that whole top line there? You're going to see this in all my code. You can squint and ignore this. And now I'm going to quickly explain it to you now. You don't really have to understand what's going on here. Your code will work fine without it. Why do I do this? It's a good habit of mine. I actually have it automatically set up in my editor. Every time I do, it adds this boilerplate there. Now, the reason I'm doing this is because I'm writing my code for a lot of people to use, and I need it to work for multiple versions of Python. So this stuff at the start, it's pretty clear actually. It says from future, which I always like. You can import something from the future. This is a very clever trick Python does when they're introducing new features. In earlier versions, they put it into this future thing, so you can, if you want, import these features and start using them. In particular, I need to support Python 2 and Python 3. They're very similar, but there are tiny differences. This stuff here imports nearly all the differences for me, so I can then write code that's compatible with Python 2 and Python 3. The reason I'm saying not to worry about this is so far nothing we've learned is really different between Python 2 and Python 3, except the print statement, and all of that. The only difference in the print statement is you now have to put parentheses around the values. So there's only tiny differences, and I was careful not to teach anything that requires them to see Python 2 and 3, which are very obscure, somewhat obscure anyway. So that's the end of that. I'm not going to mention these anymore, and you don't have to do this, except to know that when you see this in somebody's code, they are trying to be compatible with the future. John? You're scratching your head. Okay, so as I said, I've just taught you this, and now you can forget about it. So, so we have this here. So the main content of this.
The stick is right there.
Oh, bring it. I knew I had it for some reason. Right. So I just created a very simple module here. A module with two values. There's a value uppercase Tom and a value uppercase food. And let's actually do it. I'm going to import, wrong window. Import Tom. Now if I take a look at the items that are in this module Tom, you can see, aside from all these magic things here, you can see that there's food, this guy, and Tom, that guy. Ignore the other ones for the moment. Right? So then if I can say Tom dot food, and we get that list there. Tom dot Tom. Now I'm actually going, now here's a question you may be asking, what's that U in front of everything there? Truth to tell, it has to do with this. I'm going to get rid of this for the moment because, all right, I'll give you the 2-minute explanation. I swore I wouldn't ever just say, oh, I think all this is. One of the big problems in dealing with modern computer languages is they were initially designed, everybody thought that everybody would always type in English. This is not the case. There are lots of Chinese people out there. And other kind of things. So there's a whole thing called Unicode. Regular things allow you to actually represent less than 127 characters. Unicode lets you represent millions. Trouble is, if you take a string intended as one thing and use it as another, you have problems. Python 2 didn't handle that entirely gracefully. Python 3 handles it more gracefully. But in order to do this, one of the things it does, it prints out, the little U says this is actually a Unicode string. And here, let me show you here. You see this thing that says Unicode literals? That's something that's forcing all my strings that I have in any of my files to be Unicode automatically. I'm going to get rid of that though, because the purpose of this lesson is downright confusing. So I'm going to reload that, another operation. So what reload does, it only works for modules, it just brings the whole module back in. Bear in mind, little warning here, reload is not infallible. If you're actually having problems and you've done reload a bunch, I would quit Python and restart. The reason is that if you reload a module, if you have elements in that module, elements you've already created using the old module, they're going to stick around. It's not smart enough to say, oh, you created this thing using this old module, I'm going to go back and do everything you did again with the new module. It won't do that. So reload's very handy for this sort of fiddling around. It's going to work in this case, but just beware that it's not 100%. Because I've seen people get burned with this. Do you ever
That's what I'm saying. If you like set variables in a module and then you were to screw around with it in one module, but then let's say you closed the module that held the variables and reloaded it.
It's gone.
It's gone.
Yeah, it's gone. You shouldn't be doing that anyway, frankly.
Okay.
You shouldn't. If you want to save things, you should be saving in files, as we did in one of the lesson previously.
Right.
So let's do it in. If you do tom.tom, this time you should see it without those distracting years. So there's actually something I'm not sure that I pointed out before, but I want to actually point out here or reinforce is. Do you notice that I don't have any parentheses around this, but they get printed out with parentheses? Again, this is another thing that Python does to make it easier for you. If you just have a list of things with commas, it's like, oh, it's a tuple. That's how that unpacking I showed you, the multiple assignment, actually works. Behind the scenes, it makes your variables into a tuple and fills them in from the tuple on the other side. So that's just a note to ask the question, why are there no parentheses here and parentheses there? Really handy, and I just find it looks nicer, you know? Anything that involves less typing and more clarity, a big win for me. Okay, so we've just created a totally simple module that only has 2 elements in it. And there's only really one more question you may be asking. Oh, and I'm not even using my, here we go, what do we have? We'll use a camera case. Perfect. Here we go, you're on the spot. Here. Guess, which question am I thinking you should ask? This is a real guess. Anybody got an idea?
Oh, no. I don't know.
Why are these, that's always a good answer. Calvin taught me that one. Pass along the spot here. The question you should be asking is, why are those variables in all uppercase? Yeah? Question, why did I do this? Okay, there's no programming reason that forces me to do this. Although notice that, for example, it is significant if I do tom.food, I won't get anything, right? So you have to keep the case right. But there's no programming reason I can use any case alike. I can have a variable food if I like. And that works perfectly well. The reason I have an uppercase is a message to me and a message to future programmers. All uppercase variables are in many languages constant values, values that never change. Often you have things where these are values maybe that configure. You say, what's the maximum file size? What is the timeout for this connection? And that's a value that doesn't change. You often think of these as configuration values or setup values. There's a lot of different ways to think about it. But the message when you see in uppercase is, this is not a variable. This is a value that will never change in this program. So this is a convention. Really, it's a convention. It's also, the nice thing about Python is there's really one naming convention for everything called, as I mentioned before, PEP8, P-E-P-8, by the benevolent dictator for life, Guido van Rossum, who wrote this very many years ago. So unlike other programming languages, you can be pretty confident that if you go to a Python program written by some stranger and you see uppercase variables, he also means that those are constants. All right. So that's the last question about modules. So now you know how easy is it to write modules. We're actually going to start writing modules. Now, what I did, first I'm going to give you an example, which I called rather boringly example.py, of just how to build functions in modules. We're going to go through that very systematically and do dead simple functions. Then I actually have, wait for it, a poetry application for you, which I wrote. And I was very tempted because I thought, I was tempted to actually write it in front of you and let you see me make mistakes. No, I decided I wasn't confident. I actually did it. It took me about 45 minutes. I was like, I could have done it, but no. Would it be bad? There could have been swearing. I don't want any of that stuff. So I actually instead what I'm going to do is I pre-wrote it for you, and I'm going to go through each step of how I built this poetry verifier, as I call it. But let's start with a simpler example first. So voila. So this is another function, another file I called example, and let's start by importing it. So import example.
What's the definition of a module?
It is simply a file with Python code in it. That's the nice thing about it. In other programming languages, you have to go and package and all this stuff. Here, you just put Python in a file, and it is a module, and its name is the name of the file. Oh, and
Is that different than shell?
Shell doesn't really have modules. Shell? You mean the shell scripts?
Yeah.
It doesn't have modules. Actually, and I should add, there is in here. I decided because I think we're running a bit. We're already running behind on this thing. Is I have a little part of the lecture on submodules and how to do those. It's also really easy. If I have time at the end, I'm going to do this. And but it's also in the examples here, and I will have an exercise on this before. So we'll see if we get to that today. But I realize it's just not so important. We have a lot of material to cover. But bear in mind, you can make submodules and submodules and submodules, and it's really easy. It's really easy to say this directory is a Python subdirectory, this directory is not. All this is dead easy. It's really one of the best things about Python, and that's one of the things that's been there since version 1.0. Part of his vision was dead simple modules. And so it's really nice to not have to do any work to package something up. Every day I am happy about this when I get up in the morning. Well, no, about 2 hours later when I actually get working. All right, so here we go. So we have, I just imported this new module called example that I whipped up. And I have a bunch of boring functions with names like 1, 2, 3, 4, 5, and 6. So let's take a look at these. Each of these members of the module, each of these elements of the module is a function. And what I'm trying to do is show you all the different ways you can put together boring functions. None of these functions are interesting. Well, then I'm going to hopefully have examples of all but one or two of these in my actual poetry processing, analyzing. So let's start with the simplest one. Function 1. This function is a function that takes no arguments. That's what that empty brackets are. So def says, I am defining a function. Then there's the name of the function, which is 1. An empty bracket says this is a function that takes no arguments, and it returns the value 1, the string. So, here we go. If I do example.1, what's it going to print? This is a guess.
1.
Yes, very good. Pascal. Okay. So that's very simple. Oh, sorry, John. But this is John's camera, by the way.
Double check that down.
Everything's in the batteries. I have elsewhere. I didn't leave it.
No, I'm just checking to see that my
Memory cards.
polarizer is.
Oh, you polarize it. So this camera is John's camera. All of this, people online, millions of watchers who are looking at this, it's all thanks to John that this is all being videoed. I would have had to go and buy a camera, probably consuming all the money I made out of this. So it worked out really well for me. All right, so that's straightforward enough. Now let's look at 2 here. Function 2 is very straightforward. Def means you're introducing a function definition. 2 is the name of the function, and x is you call this the parameter, or another way to call it is an argument to the function. Python prefers to call these arguments, which I kind of, it's good as anything. So this is a function, def, its name is 2, and it has 1 argument, and that argument is x. And what it does is it puts, it takes that value x, puts it in that string. Remember the %s, just puts it in the string, so you get 2 and the value of x. So I see John, you're on the spot. Let's do example.2 John. What's that going to do?
It's going to print out 2 John.
2 John. Fantastic. Very easy. So there's some problems with named arguments, though. I probably should have an example with multiple named arguments. But supposing I had like 4, I can do something, I'll do something right now. Let's do 19. And I'll have arguments x, y, z, w, v. I'm going to do print x, y, z, w, v. So I can have as many as I like. 19, 1, 2, 3, 4, 5. I can have as many arguments as I like. in functions. It doesn't just have to be one argument. This is a function here. I'm starting off a function definition. Here's the name is 19. I have 5 arguments, x, y, z, w, and v, which I print out. Yes, John?
All functions start with a def?
Yes, all functions start with a def. Def means exactly and only, I am starting a function now. There's no other meaning for it in language. Always a good question. I mean, like, yeah, you hate it when you see it later and it does more than one thing. The trouble with this is, I can make mistakes. In fact, I did deliberately make a little mistake in there. V is before, if I was expecting these in alphabetical order, V is actually before W. In fact, those whole things should be at the beginning. It's easy to make mistakes if I have lists of names. And this is the trouble with those mistakes is they're almost impossible to debug if it's done a gross error, because you can stare at that spot for ages and not realize you've switched to the parameters. Bad feature. What Python introduces something that's really nice, which is named parameters. Named parameters. So here is a function with 3 named arguments. I should be calling them arguments because that's more Pythonic here. This is a new function 3, and that has 3 named arguments: name, food, and drink. These arguments have also what are called default values. This little thing, name equals Tom, says, if I don't give the function 3 a name, assume it is Tom. If I don't give the function 3 a food value, assume it is chips. Right? So this is a much better way to go. Generally, for anything other than trivial stuff, you should always use named parameters. Even this first one, Python is so good with the named parameters. This is actually a named parameter here. I can actually say, example, if I can find another type, I can do x equals John, and it'll print exactly the same thing. Or I can say 19, well, I'm not going to do that because I'm too lazy to make it too long. Let me not jump ahead. Let me show you how 3 works. So let's just start off with example, .3. And who's on the spot? So guess what this is going to do?
Tom loves food and chips.
Almost.
Oh wait, sorry. Tom loves chips and beer.
Fantastic. I don't even really like chips, but there we go. So excellent. So let's do. That was interesting. Clever a bit. So let's just say food equals veggies. It's more my style here. Okay. So what do you think this is going to print? This, yeah.
I think it's going to be an error because you don't have enough arguments.
That's not true. Yeah, that's very good. That brought out something there. So the nice thing about these default arguments is you never have to fill them in.
I got it.
Right. So in other words, you never have to fill them in. Even if you fill in one, you don't have to fill in the others. So it's very, very convenient. Now you can get into trouble with these in some languages. Google, for example, forbids these default arguments. The reason is you can just let stuff in their personal code. The reason is, there's a bit of an asterisk there. If anybody from Google is watching, yes, I know that's not 100%, but anyway. They discourage these, at least. And the reason is it's very easy to screw up that way. It's very easy to say, oh, I'm going to use the default is wrong, your house blows up, whatever it is. So, but it's so convenient. It's so convenient. Everybody does it. I do it. I don't need that much discipline in my life. So, Raymond, sorry. You look like Libby. I keep getting you confused. Sorry. So that's the key thing. Is it's a very good way to save yourself a ton of work. If often 99 times out of 100 you're calling exactly the same way. You put in a default. You save yourself a ton of work. So we can say here. Let's do something. Now here's a question. Let's do example.3. 3, and let's just say bear. Okay, but who's got you, Raymond? Who's got the? What do you think this is going to do? Notice I'm not giving it a named value.
Is it going to assign that to all of the open format characters?
Well, no, forget about the format for a second.
Bear loves bear and bear.
That's an interesting answer, but it's not correct. Well, and no, well, but it's not so bad, and it's, every mistake that somebody makes now, and I can explain why, is a mistake you will not make in the future. What it's doing is, this is not a great feature, I have to say. It's convenient, but it's not a great. It assigns it to the first one only.
That was going to be my
As
second.
it pulls these up, that would be your second bit, yeah. Basically is, each one of these things that you see is pulled off and assigned into the corresponding argument. Yes.
So if you were to put a comma and then put
Absolutely.
orange, it would be Bear loves orange and beer.
Right.
How come it's not error? Because you're not. How come it's not an error?
Well, what would you expect here?
I would expect because you didn't assign bear or name equals bear.
Oh, yes. So as I said, this is a poor, something I don't like about Python. That's just a default value. Underneath it all, it's kind of thinking about just getting these values assigned. This statement is much like this one. That's just kind of a suggestion there. So the answer is that these are positional arguments as well as being named arguments.
Okay.
But you bring up a good point. The point is that you can get into trouble with doing that. If there are named arguments, I suggest as a matter of discipline, always using those named arguments. So what I'm doing here, I'm showing you how it works, but I would not suggest doing this in practice. There are all sorts of ways to go wrong. For example, another way is I can say now, food equals lemon. And who's got this? What do you think is going to happen here? I mean, the fact it's not obvious should indicate already it's a danger zone. Right? Anything that's not obvious is kind of a danger zone because
Bear loves lemon.
error. Well, here's why. You see, and again, it's not 100% obvious, which is why you don't do this. Here's how Python's thinking. Okay, the first parameter bear is assigned to the first argument here is assigned to that argument name. The second argument orange is assigned to that argument food. Now you try and again assign this value lemon to that second argument. It's already been assigned, and it does say, as I said, one of the nice things about Python is for crappy computer languages, which aren't very good with errors generally, the errors are pretty good. And it's pretty clear. It says 3, that function, got multiple values for the keyword argument food. And it's quite true that we tried to assign 2 values. Orange was assigned to food, and then you tried to assign lemon to food, so it didn't work. Don't do this either. As I said, if there are keyword arguments, use them. The advantage is you don't have to do them in order. I can say here, example 3, food equals lemon. Who likes lemon? Name equals me. The English isn't going to be good. And you can say, so the order, it doesn't make a difference. If you use the keyword values, the order doesn't make a difference. You don't have to remember the order. And that's pretty good because in some Python functions there are literally dozens of arguments. So if you try to remember the order, you go insane. So so using the keyword for anything of 1 or 2 arguments, using the keywords every time is a great discipline. It's somewhat more work, but it will save you errors. And as I keep saying typing is fast, debugging errors is really slow. A little extra typing to ensure your program. There's a concept, I haven't forgotten you've asked this question. There's a concept we use all the time in programming, it's called brittleness. You say, your program is brittle, your program is fragile. What this means is, it works, but because of things like not using named keywords, it would be easy to make changes that appeared to be correct to your program, but in fact broke the program. That's the idea of fragility, brittleness. And you don't want that. It's like trying to build the classic thing I think of is Meccano. Do you have Meccano? Is that American as well as British?
Take your toys.
The game with the beads.
No, oh dear. Maybe you can. It's a thing. Basically, you have these little plastic girders that you glue together, put together plastic bolts and things like this. You must have something. Erector sets. Are those what those are? Something like that. Oh, jeez, terrible example. Well, just imagine you're bolting stuff together. If you can bolt something like by hand for a little tiny structure. But if you build a big structure and you didn't tighten all the bolts, even though each individual thing is pretty tight, the whole thing would be really wobbly because it gets worse and worse as you go. elements of fragility, little things like that, when you see them the first time and when you're a young programmer, I have arguments with younger programmers all the time. Now, the advantage of being older and eminent is now they believe me, I can just tell them. But before, people are like, oh no, but it's obvious, I won't make that mistake. You're like, yeah, you won't make that mistake. There's 100 possible mistakes. You will make that mistake, or someone else will make that mistake. I remember you program when you're tired sometimes. You program when you haven't had enough coffee. You're not always Superman. The way you prevent yourself from making mistakes by constantly using discipline in order to prevent yourself from making mistakes. And one of these is using name parameters. Soapbox over. Now, so, yes, now your question.
A quick question. Can you assign the name parameters to other things like strings?
Oh, it can be anything you like.
So you could assign it to like none and then give it a value later?
Perhaps I'm not understanding you there.
So like let's say you had food equals none.
Yeah.
And then let's say in your function you wanted to assign a random integer to that.
Sure.
Is that possible?
Oh,
And
sure.
then
I mean,
you
the way,
could call, and then could you call it using the same?
absolutely. Oh, so here's what. So that's an interesting thing. That's actually you're getting to something that's a very useful Python convention is. Sometimes you want to pass in a value and say, okay, compute this value for me at runtime. There's a convention. There's a special variable which I don't know if we even discussed called none. Have I ever talked about none with you? Well, none is a special variable whose value is none. And the thing about none is it's false. False. Remember we talked about it being false and false e, so it's false e. So you should say if none print false, and oh right, sorry, right. It's false e, right? Of course.
Yeah.
So it's not going to do that. But if I say if not none print false, then it's going to print the value print false, and it's not a number as well. It's not anything. It's a known thing. I mean, it has its own type. It turns out to be its own type. But it's so you can if you assign a value to none, something none, you know somebody means don't put anything in there. Whereas if you gave something a value 0, you might actually want to use the value 0. So none is a really good thing to use, precisely in the case where you say, oh, I want to indicate that you're supposed to pick a value at random. So, so you might do something like def, let's do import random, just is it random dot randint?
Yeah. Rand with a D.
Rand, just rand.
Rand, yeah.
Randint or just rand?
Randint, you got it.
Oh,
And then you needed, yeah.
23, let's see.
You need like 23 and then the low and the high.
Thank you. So let's do 0, is this right?
Yeah. And you don't need a third one.
Right.
Yeah, pick 0.
There we go, pick 0. Okay, that was a surprise. Okay, so let's get, let me quickly do this example here. We'll define something like def myrand number equals none, right? And then I say if number, I'm going to use something else we haven't seen before, is none. Number equals random.rand int 0,23. I hope I got this all right. And then we're going to do myrand. First we're going to do myrand 12. Just going to print 12. If I do myrand without a value, it prints some random number. So let me just scroll back because we don't get too much on this tiny little screen here. So excuse the repetition. That's just how things enter there. So I actually say if number. So I take this number and I have the default value for that is that special value none. You're going to see this all the time in code. So if the number is none, you're like, what's this is? I haven't shown you is yet. Basically, you can get by almost certainly with never use is. I would recommend not using it because you can get yourself into trouble if you don't fully understand it. But is equals says, do these two items have the same value? Is says, are these exactly the same value? Let me digress here because you'll be reading other people's code. You should know what is. What is. That's going to be my next lecture here. So here we go. If I have A equals 1, 2, B is equal to the same thing, 1, 2. So we have A equals B. Who's got the stick? Or whatever it is. That's you. What's this going to print? What's this going to do? It's easy this.
1, 2.
No. I'm comparing these two. So we have A is this, B is this, and now we're comparing. Is A equal to B? What's it going to say?
True.
True. And that is true. Hand it on. So let's do A. So let's say A is A. What do you think it's going to be?
True.
True. Pass it on, Eve. So A is. So what about A is B? Let me scroll back up again here. So I assigned A to a list, and I assigned a list that looks exactly the same to B. What's it going to say when I say is A is B? Guess. This is a guess.
False.
False. Very good. False. Well, you should. Yeah, of course. I was leading up to this. Is so what it says. So is says are these actually pointing to the same item? This can be. The thing is it's much faster to do that. Like when it says is list 1 equal to list 2, it actually goes through all the elements. I mean, until it finds one that's false. But if they're exactly the same, it has to compare every element of the list. Those could be huge lists. If you say is, it actually just looks and says, oh, is it the same thing? It does it instantaneously. So is more efficient to use, but you can get screwed up because you look at these things like, well, why aren't they the same? The answer is they have the same value, but they're not the same item. So is false, but equals is true. You can always say such and such is none, because there's only one none in the world. That's one of the reasons you use it. It's incredibly fast to compare things to. So that's a bit of a discursive answer to your question, but it's that's the standard way you do it, is if you want to say, okay, I don't want to fill in this value, fill it in yourself, you give it a default value of none, and that's why none exists. It's a default value that has that's none. Easy enough. Good choice of name too. Okay, so back to ways of calling functions, and that, I should add that this is everything we see in example is just ways you can call functions. There's a name for this. It's called the signature of the function. The signature. So, for example, the signature of this function is nothing, no parameters. This is something with one parameter. The signature of this has 3 named parameters with 3 defaults. So you don't need to know that term, but people use it all the time. You say, oh, but what's the signature of that function? And they're asking the question, how do I put in arguments to that function when I call it? It's a shorthand way of saying the signature of a function. So now we're looking at function 4. This again uses a new value, the star keywords. Now you've never seen star before, I guarantee you this one. Well, maybe some of you have, but reading ahead, but that's a new thing. Well, so what happens when you want to call functions and you don't know what keywords you want in advance? And you're like, why would I want to do that? Well, there's a bunch of reasons to do that. One classic reason you want to do this is often you're putting together a function from other functions you haven't even seen before. So you may want to take some arguments and pass them onto another function, but you don't know what legal arguments that function is going to have. Okay, that's maybe not a totally clear example, but maybe a lot of the time that there are all sorts of very practical reasons, and you'll discover these as we go along, as to why you may not know when you describe a function what the keywords, what the argument names are going to be. That's what this star thing is. That is kind of a sweep up, it's a catch-all, and it says, okay, this keywords gets a dictionary with everything, all of the keyword arguments that have not been consumed, that have not been already read by, haven't already been listed. And that's probably not so clear. In fact, let me do a very simple one where I say simple star keywords. And we're going to just print keywords. Okay, so that's pretty straightforward. So let's start off with simple with nothing. Okay, so in other words, this is a real guess, John. I'd be shocked if you got it. What do you think that's going to print?
I don't know the answer.
That's always good answer. As I said, I wouldn't be shocked. It's an empty dictionary. Empty dictionary. So you're like, okay, well, why a dictionary? Well, the reason is, supposing I say simple 1 equals hello. Pass it along. Guess what this is going to be?
Hello in the dictionary?
Very close.
Just hello?
We can't. You always have to have a key and a value for each thing, right? In dictionary, key.
Oh. 1 colon hello?
Da-da-da. Right? So I can then do, I can say 2 equals goodbye. What do you think it's going to print?
1 hello, 2 goodbye.
As well.
As a dictionary.
Yeah, exactly. Who's next?
How come it always switches 2 and 1 when that happens?
It's random.
Okay.
It's not always. You don't know. Oh, yeah.
How come 1 becomes a string? It's like 1 equals hello and like hello is a string.
Interesting. It's because forget for the moment about the second half here. You always call functions with a keyword name, which has to be a string,
Okay.
and then some value which can be anything.
Okay.
When it translates into a dictionary only, it makes it a string because that's what it is. So, but that's definitely a good point. I mean, it would be annoying if you had to put quotes around those, since you'd always have to do it for no value. That's why there's no quotes. Simple enough. Let me do another. Who's on the spot here? Okay. Well, I didn't spell that right. What do you think this is going to print? Guess. It's a trick question.
It's an error.
Very good. Got a new one. And look, again, Python's giving us a good element, error. In fact, I could have told you what this error is going to be, so I shouldn't act surprised. It says it's not so bad. It's as simple, takes exactly 0 non-keyword arguments. Right? If you look at the definition of simple, it's absolutely true. Somewhere way up here. Well, it takes all of these arguments are keywords. All of these arguments, because of the star KWD, all of the arguments to simple are keywords. There are no what are called positional arguments, none whatsoever in this. So it's pretty straightforward. We've now created a function that can only be called by keyword arguments, which is really nice. So with this we don't run into that problem before of being able to call something. With argument, just plop an argument in and have it randomly assigned to the first one. The downside is, of course, we don't know the names of any of these keywords. It could be anything. So, okay, I'm going to stop and ask a question because this is a little bit tricky, this one. In fact, just think about it for a second, and then if you didn't ask me anything.
So a keyword you can make up kind of as you go then, like.
Well, if your function has, and that's again, you see, this is why you need to. This is why questions are good. That's a very, very good question. If there is a star field, then you can make up any keyword you like.
Okay.
If there is not, if there is in my example here, 3, you cannot make up keywords for this.
Mm-hmm.
I can say, so if I say, well, I won't even give you an example. If I say 3, wombat equals marsupial, it won't work. So in this case, we've named, there are only 3 possible keywords here. Name, food, and drink. That's it. You can't add any more, you can't do anything else. If there's that star field, you can use any keywords you like in calling. Jump.
Is it always star?
Yes.
KW?
Oh, no. I could make, 90% of the code you see will use KWS, but it can be anything you like. People just tend to do it that way. I don't even know why. It's not even, you're not required to do so, but it's easy. Ring.
I'm still a little confused as to what it's doing. So, star keywords, like can you use function for an example?
Function for an example. Yes, why don't I use function for in an example? Good idea. That's why I had it. So we say for example.for. And let's take a look. So we have name equals Ray. Are you ever Ray or Ray?
Ray's fine.
Ray's fine. Name equals Ray. Food equals avocado. If I spell that right. And drink equals whiskey. You may be a teetotaler, but you're out of luck. Okay. Voila. Who's on the spot? What do you think it's going to do?
Ray
So,
loves.
Oh, sorry, yeah.
Ray loves avocados.
Let's find out. Oh, how embarrassing. I didn't test this all out, and there's an error here. So we're going to fix this up. How utterly embarrassing. People at home, don't watch this part.
Could I also ask why you had to do example.for?
Because remember that this here we're showing is a module.
Oh,
This is
right, so you're pulling
so
from it.
I imported everything, and then all of those become underneath that envelope.
Right.
So convenient.
But if you did import for from example, then you could just do.
That is absolutely right. I haven't even gone into that, and it's a good reminder that. Oh, I think I actually did that. Did I do that in the lessons, in the exercises? I did not. I don't think I did. I will put an exercise in. So let me do this correctly, though. I'll do my own version of this, and I thought I tested everything. I tested the big example, okay? And voila, star. Oh, how embarrassing. So for let's go. Actually, I haven't been there. Oh no! I made my own version. It's like finding out. Thank you. And this brings up more good stuff. Every time somebody asks a question, I learn something, even if it's that I don't test all my work. Why the star here? What's going on? Well, here's the thing: sometimes I intended this example of what I was saying before. Of sometimes you don't know what arguments the function you're passing things on to are going to take. That's why you use star keywords. So here in this example, you're saying, okay, any possible arguments can appear here. Throw them into a dictionary. Then when I use the star again, I'm saying, okay, pass those arguments as is to this function. So that's a way you can also call functions. Instead of just calling them, you can build up a dictionary and then pass it to that argument of that function using star. So given you understand the first meaning of star, which I don't think is a given yet because it's pretty tricky, the exercises will definitely help here. The second meaning means exactly the same thing. It means take the reverse, rather. The first one means take all the arguments that are left over, throw them into a dictionary. And then putting star, so that's when you use star in the definition of the function. So this star definition says, take all the remaining keywords, which is all the keywords in this case, and throw them into a dictionary. Call it keywords. When I call a function with star, that says the reverse. Here's a dictionary, throw all the values of this dictionary into the keywords.
Is it taking it from definition 3?
Which you mean? No, those I perhaps shouldn't have made them so similar. 3 is completely independent.
That's what was confusing. Okay.
Sorry about that.
So for allows more like flexibility.
Yes, much more flexibility. It's extremely flexible. Again, the trouble with that is if I read the top of 4, I don't know what arguments are expected and not. So in that sense, it is more fragile because I can misspell arguments and it won't come out until later. So it's not entirely a good thing, but you do use it quite a bit because a lot of the times you don't know. You're putting together functions and this sort of thing. We're not really probably going to have a great example of this in the course. This thing called decorators, which is ultra cool, and I will show you how some decorators you will use later, but I won't show you how to build decorators. But use this all the time. It's a very useful technique. And you'll see it in code, that's why I feel I should do this. So let me just repeat this. When you have an argument which starts with a star in a function, that means it's like a garbage box. Throw all the named keywords into that dictionary. When you call something, like where my little hand is there, when you move it slightly out of the way, when you call a function using star, that's the reverse. Take that dictionary and throw all those dictionary values into the keywords. Yes?
I have a question. Could you do also definition 4 using format characters instead of the
Sure.
other? Okay.
Yeah.
And then you would end up assigning, it'd be like %s, %s, and then at the end you'd assign.
Well, then I'd have to actually pull out the values from the argument. I have to say that I feel here that I was unfair to you because we spent very little time in the class on this format, and there were some exercises and things, but it's more complicated, and I didn't expect you to fully understand that, but so to use that example was a poor choice of this sort of thing. I will give you more examples, so I'm guessing going to revise the homework somewhat here, but I'm going to give you more examples of this in the homework, and hopefully it should let you work it through. But I think the takeaway for the moment is star means a grab bag for all the keywords that I haven't named.
So star always refers to a dictionary, right?
Yes, a dictionary as an argument even.
Yeah.
So it's star has always arguments in dictionaries. Did you have your hand, or were you just scratching your head?
So if you were to, whatever, like executing this module,
Yeah, function.
and function, sorry, and you weren't, when you did it before, you were like name equals ray, food equals, if you did it without naming them specifically, would it still the order, like the first one gets filled in?
Oh, no, because you see, if you use star keywords, you're saying, take all the named arguments that I haven't mentioned. If you don't name those arguments, they don't get put into keywords.
So it's not like the default where the first one is automatic.
That is right, it's not like
Doesn't
default.
work with
It doesn't work that way, it'll just fail. In fact, if I say for Ray, you will see there'll be an error.
But what if
Oh,
you
sorry,
did,
yeah, right.
what if you did like a tuple? So if you did like
Still won't work because they're not named.
Ray.
It still isn't going to work because they have to be named arguments. Star means named arguments. So whenever you see star, it means you're moving between a dictionary and a named argument. One of the things is, as I keep mentioning, is Python is very parsimonious. It's cheap, stingy with its ideas. Everything is a dictionary. I mean, conversely, what it means, they put a huge amount of work into making dictionaries work very, very efficiently. But so everything is a dictionary, and it turns out that all your arguments you pass are basically a list in a dictionary. That's how it's done behind the scenes. Pretty well everything is stored as a dictionary. Like a module basically is a dictionary. It's just a dictionary from the names of things in the module to the values. Everything's a dictionary. So let's go on a bit here. And I probably should have made 5. I should have made 5 earlier here. So now we're doing yet another new concept. That's single star. Single star. So as I said, we should have done single star before double star, right? And again, is the star. Whenever you see stars in arguments, you're like, it's the garbage thing. It's the thing you throw in when for everything else. What's it called? A catch-all. That's a better term. So in other words, what's left over is thrown into the thing with the star, or thrown into the thing with the double stars. The single star argument contains positional arguments. So that's kind of what, Raymond, you were asking before. You wanted a grab bag for positional arguments, and you've got it. It's these star args here. So let's actually take a look.
Okay.
Right? So example.5, Tom. Okay? So there's one named argument here. There's not one named argument, there's one positional argument here, name, and then everything else is optional. So who's on the spot here? What do you think this is going to say? So here's the definition. %s, the first thing loves, %s, which is the join. Remember how we join things with the spaces in it? So let's go through this actually. So Tom gets assigned to name, the argument name. Now args is a list or a tuple. You okay?
Yeah, no, just make sure
Oh, dear. Well, don't say too heavily. So args gets the remaining arguments and helps that there are no remaining arguments. So what do you think this is going to print?
Tom loves Tom.
Oh, that's not true, but no, it's because we've already consumed that first argument Tom. That's already been used. That argument Tom is being assigned a name. Args has the remaining arguments, which is what? Nothing.
Tom equals none.
None's an interesting idea, but no is, well, let me just, here. What happens when I do space, here we go, let's try this one, dot join the empty, let's make an empty list so it's a bit more obvious. So let me change the question to that. What's that going to do? What are you going to get out of that? Well, so remember what join does. It takes all the items in a list, or tuple, or any iterable, and glues them together as strings with spaces between them. This was actually an example, a homework example. So this is the empty list with no items in it. I know it looks like a box, I'm sorry, the font, there's an actual gap between this. So there's, in fact, look, spaces are free, I'll put a space in there, right? So this is the empty list. So it's going to join every item in the empty list, i.e. no items, with a space. So I'm going to get the empty string.
Yeah, not even a space.
Not even a space. Because it puts the spaces between items.
Right.
But there are no items to between.
That makes sense.
You really actually need to have two items before the space appears. Even just one item, you just get that item. So 0 to item. So, if I didn't cut, no, I didn't do that. I thought I cut this. So, okay. So, you can pass it along.
Question about 5 though, like,
Oh, I'm about to do 5. So, well, let's do it actually. Let's do example dot 5. And I may just ask you again, Tom. All right. So, hang loose for a second. I know you're next, but we'll put you on the spot here again.
Well,
Oh, I meant. Yeah, didn't mean you. Sorry, fingers.
because Tom's assigned to the name,
Right.
and still, there's no other arguments, but it still wants to return loves. I mean, it won't print anything with the love. That's what I'm not getting.
Okay. Well, let's go through this. Let's go through this bit at a time. As I said, these are intended to be, of increasing difficulty, and this is why this is the tricky class. I'm thinking I should have probably had 10 examples. I think I've rushed through these too much, so it's very educational. I should be paying you, but I won't. Okay, so let's go through this here. So all your reasoning is absolutely right. You're just insecure about coming to the right answer. I mean, everything you said is correct. You're absolutely right. Tom, the first variable, is assigned to name. You're absolutely right. Args is now empty. It's an empty list. Well, it's an empty tuple, in fact. So what we're going to get is, here we're going to get the string. What's it going to say?
Tom
Not quite.
Tom loves.
And
That's it.
Blank.
that's it. Right. Very good. Oh, they do. Oh, it did. I hate computers sometimes. Let's do this right. There we go. Tom loves, exactly right. But then I can do things like, I can say things like, you've got the stick. Tom loves frogs. And what's this going to print?
Tom loves
Oh, yes.
frogs.
Why did I tell you the answer? Pass it on. Well,
Sort
okay.
of like an empty placeholder.
Yeah, it's exactly right. But it said, what? Okay.
So it won't, and didn't print there, and like love, when you only had one variable, loves didn't print, so it only prints up to the last variable that you assigned.
Not sure I understand your question. It did print loves.
Well, but so you gave it Tom and frogs,
Right.
But it could give you. Am I looking at?
You're
the
looking
wrong
at
module?
5.
Oh, I'm looking at 4.
Oh, actually,
Oh, I'm looking at. I'm
let me
I'm
actually
looking
know
at the
what I
wrong
can do here.
function in your
let's make this even bigger.
Tom.
So there we go. Sorry, and let's scroll down here. Voila. So that makes it a bit clearer. I'll leave it this time.
No, I see.
Oh, I'm just. I was.
Well, so
I was looking at 4. That was my mistake.
well, yeah, right, but I shouldn't be encouraging, error by having the wrong, Now it's nice and big, now we can see everything. So let's say frogs and snails. Frogs and snails and puppy dog snails. Nobody knows that one, right? It's an old British nursery rhyme that said, what are little girls made of? Sugar and spice and everything nice. What are little boys made of? Frogs and snails and puppy dog's tails. Probably written by a woman. Sorry. Okay, so what's this going to do?
Is it an error or?
Nope.
No.
No, okay, let's go through it again. So remember, this is a catch-all, a grab bag. The first argument, Tom, goes into name. Then args is a list of all the other arguments.
Perfect.
So just all that crap is thrown in there, so we get actually a tuple, not a list. Okay. A tuple containing frogs and snails, so it's actually going to say,
Tom loves frogs, snails.
right, no and there. I'm actually going to, here we go. Oh, go ahead, yes?
Could you make like that more complicated and then like how would you iterate the amount of arguments if you wanted to use an if clause?
Oh, you can just say, you can say, you can,
Args, like if you wanted to add and if you were using 3 arguments,
right.
which seemed, how would you do that?
Basically, you could use, remember we have that length function, len. That's how you do it. You could even just use join, you could do join, you could use for your join value space and space.
So it counts it as like length where it normally counts like a character. It's
No,
counted
it
each
counts as the length of it would count, you could apply, I'm not going to go through this because it's a bit time consuming to actually make new functions on the fly. This is a tuple. I keep emphasizing the tuple. I'm going to ask you why in a second. It's a tuple, not a list. This is a tuple. I can take the length of that, and that will tell me how many arguments are left over.
Got it.
So that's kind of that's how that works. So you could make decisions based on that. So here's the question: why is that a tuple? Why is that not a list? John.
Because they could be different kinds of values. They could
That's true.
be
Lists can have
strings.
different kinds of values too.
Because it's positional?
But lists are positional too. This isn't quite a trick question, but I would be surprised if you got it.
Because the data is not ordered.
But tuples are ordered. No, this is, again, trick question. No, not a trick question. Subtle question is, why is it a tuple, not a list? What's the difference between a tuple and a list? Do you remember this?
Tuple can't be edited.
That's right. Tuple is invariable. It is immutable, is the math term. You can't change tuples. You can't assign values into it. You can't change the length. They're immutable. You want that. You don't want your code to be able to change the arguments on the function that you added. You did that. You don't want that. That would be bad. It would be very, very unintuitive. And also, it allows them to be very, very efficient. If they know that those tuples, that value never changes, they can just say, okay, I'm going to put, it turns out they put in a special memory thing that can't be cleaned and this sort of thing. It's very, very efficient to do it that way as well, but it's also conceptually nice. You don't want to be halfway through a function and change the way you call it. If you needed to do that, you could just make a copy of the arguments and change those. So the reason, whenever you see something there's a tuple over a list, it's nearly always because it is immutable, that you don't want to change it. You want to enforce a lack of changing on things. And again, we get back to fragileness and brittleness in code. Anytime you can use a tuple, you should, because it indicates your intention. It says, this cannot be changed. I do not want to change this. Every time you can use a tuple, you should use it because it makes your code less brittle. It prevents, later on, if you decide, oh, I do need to change it, you can go and change it to a list that takes you 2 seconds. But it will prevent you from changing it accidentally, somewhere else by mistake. And the number of times this will save you is huge. So that was a quick digression. Why is that a tuple? Why are these of the args? The other question is, does it have to be, nobody asked this question because you're probably satisfied about the keywords, does it have to be called args? No. It turns out in most Python code they use KWDS and args because they're quick to type and that's what people have been doing. But nobody requires you to do that. Yes?
So if you had 4 arguments instead of 3,
Yes.
would you have a space between the third and the fourth?
Let's do it. Please. Oh. Voila, snails, toads. Okay, and we're going to say Tom loves frogs, snails, toads. Easy enough. Oh, right, and now we get to our final example. Number 6. This has everything. Okay, so let's go through this. So, we have one positional argument, name. We have one named argument, rank. We have a bunch of the remaining keyword arguments are in args. The remaining positional arguments are in args. The remaining positional arguments are in args, and the remaining keyword arguments are thrown in keywords. But this is it. This is as pathological as you can get. I mean, you can have a few more of these. That's as far as you can get. You can't get anything more complicated than this, so I thought I'd show you the worst you could possibly see. So let's try it out here. Okay. And again, so I expect long pauses. You figure this out. I'm going to use my name again because I'm being abusive here. And let's just put some other arguments. Let's say Tom, Wombat, friends equal none, enemies equals everyone. All right. So there we go. So I'm then going to try and get you to guess what this is. I'm going to press return, and we get the whole thing. We get the whole thing printed out here. And so let's go through what's going on here. Okay. So I didn't use. Did I use? Why didn't rank? I'm surprised that rank didn't appear. Oh, that's annoying. Okay. Yes, and again, you see one of these problems here. It's kind of annoying. Let me do this again. You may want this. So let's say rank equals loser, and then Wombat. So sorry. I should know that's going to happen. Okay, rank equals loser. I hope this will work. Well, okay, so this was a very poor example. I don't know what to say. I can't really give a good way to show this off. I'm so sorry about this. I mean, it worked, the original example worked. Like, the trouble with this is that there's, the way I've set this up, I way over complexified this is, there's no real way to use this toilet cleaner value to have it come out. So, I'm debating.
Is that because of the args?
Yeah, it's because basically I put everything in. The trouble is that I have no great way. I can say something like, I guess what I can say something is like this. I can, you will see toilet cleaner appear in this case. I should have done this in the first case. So if I do I did test this. I didn't test this one enough. So if I do this, it's going to say Tom is a toilet cleaner, which is what I intended to do in the first place. It's not true though. I did it. There's deals. My wife does the toilets. I do the dishes. We switch.
That's not sound fair.
It's true, but there's a lot. But the thing is, it's a lot. No, here's the point: is there are a lot more. We get 2 loads of dishes a day. We clean the toilet once a week.
So you went on that.
Okay.
So time consumption is much bigger. Right. So that's worked out.
She does most of the cooking too.
She does do most of the cooking. It's true. Hey. It's true, but still, she likes the cooking. She hates the dishes, so it's kind of a deal.
There you go. Everybody has balance.
Everybody has balance. It's a deal. Okay, this is off the record, internet. Don't repeat this. Luckily, she's not going to see this video. I can show you. So there we go. Okay. So what's happening here? So Tom gets assigned into the first positional value. This one gets a default value. There are no extra arguments. There are no extra keywords. I could and I could do something like and we could do frogs equals toads. No, that's not true either. But there we go.
Could you, can you put Tom, comma, rank, comma, frogs equal toads, and it'd be Tom is a toilet cleaner?
Oh, you mean like this? We could do something like, well, I could do something like this. I could say, comma, rank equals general. I'll be promoted, and then you could do that. Yes.
Oh, okay.
Right, and so, and again, I'm gonna keep all this transcript. I've also, you notice I'm putting this in a different thing where it'll be much easier for me to keep the transcript here. For you next time. So I'll let you have this for next time. So I'm expecting to play around with this. There'll be stuff in the exercises. So what's happening here? Tom is being assigned to that first positional value. Now then this keyword value frogs isn't used, so it's thrown into keywords. This keyword value rank is named, so it's put there. into that value. So at the end, what we do is we get Tom, that's the first positional value, name is a rank, but remember we got the rank from general there. And then there are no other arguments, and all the remaining keywords are thrown in. All the other keywords are thrown in this one box. This box of keywords there. So right, so no trouble. So what's wise? Okay, so that's. I think we should take a break here. This is, as I said, I went through quite a bit of material here, and I probably should have twice the number of examples with half the speed. So, but don't worry, you'll make it up in the exercises. We're going to take a quick break, like 5 minutes, chance for a cigarette, which I smoke cigarettes, and let me pause this, and then we'll come back and we'll actually do a fully worked out program.